I'm going to show you how to approximate the area of this shape using just a measuring rod and measuring rope. The procedure is to subdivide the region into rectangles, right triangles, and right trapezoids. Now the tricky bit is getting those right angles just so, which is why we have the measuring rope. We're going to start by putting in a central rectangle with the proportions 3, 4, and 5, that is to say, a short side of length 3, a long side of length 4, and a diagonal of length 5. This makes a mathematically perfect rectangle because 3 squared plus 4 squared is 5 squared, and all you need to construct it is a measuring rope. So the first step, make a measuring rope. We're using this measuring rod, and we're going to say this is 2 units long. And so you get your rod and you mark it halfway between, and then you mark out lengths on your rope for every unit. So just you can see this, I've done this before. I'm going to measure just one there, and then a unit further along I'm going to measure one of those. And the more accurate you make this, the better looking your right angles are going to be. You need 9. You need 9 units on your measuring rope. You'll see why in a second. So let's begin. We're going to make a rectangle right in the middle. I'm going to start by measuring 2 points 3 units apart. So here's going to be 1 point up here. Here's going to be another point. 1, 2, 3 lengths down my measuring rope. Good. Now, hold your measuring rope, either end of your measuring rope, on those 2 points. So using your fingers, just press it down there, and press the other end down there, and hold them on those points. And then take your pen or pencil and measure 1, 2, 3, 4 lengths across that way, and the remaining 5 will be along the diagonal. And just mark out that point all the way out there. And then, so that would make a length 4, that would make a length 5, completing the other. And this point is another corner of our rectangle. And then do the same thing down here, just pull the rope taut. And that's going to be down here. Again, length 4, length 5. So that's that point there. A good thing to do is make sure that these points are in fact 3 units apart. And if they're not, you might need to go back and just measure that again. So these don't look quite correct. So I'm going to go back and just make sure I've got those accurate. Otherwise your rectangle is going to be a bit wonky. And I can immediately see that actually I haven't done that one quite correctly. So let's go back and do that again. I'm going to put that there. I'm going to put that there. Something's gone wrong with that point. And so we want 1, 2, 3, 4 up that way. Okay, that looks better. 4 up that way. And what about this one? Is that still good? Yeah, that one looks reasonable. Okay, so now I'm going to measure that again. Is that 3 units across? It looks pretty close. Looks pretty close. Okay, so let's roll with it. Pretty good rectangle. Good. And I know that length is 3 and that length is 4. The area here is going to be 3 times 4, which is 12. And now what I've got is a big central rectangle whose area I know, and I've got all these other shapes floating around. This one up here, and so all these are going to be right angles, like so. All these other corners here are going to be right angles as well. That means this one is a right trapezoid. This one here is a right triangle, right trapezoid. Treating the shapes in this way, I'm going to lose parts of my shape, like I'm going to lose that area there, lose that area there. That's fine. It's just an approximation. For our purposes, that's totally fine. So now we can go along, measure each of these perpendicular lengths using our measuring rod and figure out what the total area should be. I'm just going to go do that now. Good. So I've marked out all my lengths and I've measured them, and so I can start computing areas. Good. And so these are each of my individual areas, and the total equals the sum of these parts.